Okay, for this video, we're going to show how to find the volume of a solid generated when the region bounded by y equals x squared, x equals 2, y equals 0, and the object is revolved about the x-axis. All right, let me get my pen. Right, we want to find a volume, three-dimension object. Solid generated by three things, by this y equals x squared, we need to graph this upward parabola, x equals 2, a vertical line, y equals 0, which is the x-axis, right? Well, let's graph first. So I have my x, y axis, so x squared is, should I change my color? Let me change my color. So I have an upward parabola, which the vertex is the origin. Right? So this is our x squared graph. And x equals 2. Well, let's see, 2 is somewhere here. X equals to 2. So vertical line, x equals to 2. Then y equals 0 is just x-axis, right? So the region we see is bounded by these three things, which is this. And then it's revolved about x-axis. So the symmetry is x-axis. So we need to graph this, right? So when we revolve with x-axis, we get a 3D objects. And the intersection are perfect circles. So let's graph circle-like. So this object looks like a home, right? Looks like a home. All right, that's it. When we find the volume of this. So how do we find the volume of this? First, we want to take from 0 to 2, x value from 0 to 2, set up an integration. So this is one dimension. So one dimension we want to fix as x-axis. Because x-axis is easy, right? Going from 0 to 2, because this is a x equals to 2 line. So the lower limit is 0, the upper limit is 2. So this is a one dimension value. Now, how do we get other two dimensions? If you look at the intersection, a perfect circles, right? Perfect circle. So this would be the biggest one going through x equals to 2. Then going from the inside, you see circles become smaller, 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 and smaller. Then the last one is the origin, right? It's a point. So we're going to add up. We're going to find the values of all those area of the circles. Then add up. How many we have? We have from 0 to 2 many, right? One dimension we already have. So the x-axis will cut into infinitesimal units, 0 to 2. That's how many circles we have. But then we want to find the area of each circle. Well, area of each circle is pi r squared. So where do we get the radius of r? If we take a look at this, let me change my color, maybe to be blue. You see, let's see the biggest one, bigger one circle, the biggest one, biggest circle, right? So radius is just this. This is the y value of this parabola. Just x squared, right? Just x squared. So r equals to x squared, which is the y value of this parabola. Okay, that's it. So our integrand would be the area of those circles. So we add up how many? We add up from 0 to 2 many on x-axis. So pi r squared, r is x squared. Then r squared, so we need to square this. Well, pi is a constant, so we just factor out outside of the integration. So x squared squared, that's x raised to the 4th power. Then we just integrate, right? Integrate x to the 4th power. Well, it's just by power rule. We add 1 to the exponent, which is 4 plus 1, which is 5. Then we divide it by 5. Then we evaluate at the lower limit 0, at the upper limit 2. At the lower limit 0, we don't get anything because 0 raised by 5, that's just 0, right? We just have to evaluate at the 2. So we get a pi times 2 raised by 5 divided by 5. Well, 2 raised by 5 is 32. So 32 over 5 pi. For pi, we just leave as pi. Okay, for for calculus, we never really approximate pi. So the volume of such object, this home, is 32 over 5 pi, which is pure mathematics, calculus, pure calculus 1, calculus 2, calculus 3, except business calculus or some other kind of calculus with applications. But in the beginning, just pure mathematics. Okay, hope this makes sense.